Hello, this video is for CIS200 Unit 8 challenge work. So this is on page 16 of lesson 3. You'll go ahead and click Launch Activity within the Exeter LMS. It opens up Unit 8 challenge work. You'll click Start. I already have it open. It's 3 questions. Keep in mind they may be ordered differently. So we're going to read about the Chinese cryptographer, shorter way to produce 2 different messages, etc. And we're going to answer A and B. Alrighty. So I'm just going to go ahead and explain everything here. So I'm just going to go ahead and list it as basically the, we can call it core concept. Message integrity. Go ahead and do bullets. How? So when you send a message, you run it through a mathematical formula called a hash function to generate the hash, which is a unique digital fingerprint, right? Call this one gold. Changing even a single letter of the message during transmission means the hash changes completely. This alerts the receiver that the message was tampered with. This one we can just name after the Chinese cryptographer. So we'll call this part the rule. For a hash function to be secure, it has to be collision resistant, right? This means that two exact messages, or two different messages could never produce the same hash. Call this one something like discovery. In 2005, Chinese cryptographer Wang shattered trust in the SHA-1. They discovered an efficient shortcut to create two entirely different messages that produced the same SHA-1 hash. This meant an attacker could alter a message without being detected. Call this one solution. So we'll go response. One second. So where were we? Yep, response. After realizing that the SHA1 was compromised. NIST launched a public global competition in 2007 to design a brand new ultra secure hashing standard. Winner in 2012, an algorithm named Kasek won the competition out of dozens of entries. Unlike older algorithms, SH3 which is Keswick. So SH3 was a unique mathematical design called sponge construction. This ensures that the flaws of SHA1 could not happen again. All right, so you'll go ahead and save this document, then save it as a PDF, right? And we'll come over here, we'll upload file, upload that PDF, and then we'll move on to the next one. Now this one, I'm going to use my cursor, right, to show you how we would do it. I may type one or two things, but other than that, I'm only really going to type the solution for this specific decoding of the ciphertext to find the plain text. So our secret key is peanuts. And this is our, let me go ahead and copy that secret key. And then this is our received message that we need to decode, right? So we need to have the same number of letters in each. So P matches D, E, R, A, E, N, V, U, Z, T, U, S, Q. And it looks like we have A, E, N, Q. So we repeat peanuts till we have the same amount of letters in each one, right? Okay. So we're going to go ahead and call this solution. And then we will see that. So we're going to take P, the first letter in the key, and we're going to match it. We're going to take the row that starts with P, match it to where we find D in that row and go up to the top of the column to find the actual letter that it represents. So let's try it out. So we have P. This row starts with P, right? We're looking for D. So we'll go right here. Here's D. We'll go up and we see we have O. So the solution starts with O. Now we have E. We're going to go to row E, find R, and go up to the top of that column. E, R, go up, N. Now we have row A. We're going to find E and go up. Row A, we're going to find E and go up. It is E. Now we have row N looking for V. There's V. We're going to go up. It is I. Now we have row U with letter Z. Letter Z, we go up. It is F. Now we have row T with letter U. Go up. It is B. Row S with letter Q. Go up. It is Y. Row P with letter A. Go up, it is L, row E with letter E. Here's row E, we find letter E, we go up to the top of that column right, and we see it is A. Row A with letter N. Here's row A, here's letter N, we go up, we see it is actually N. Row N with letter Q. Row N, letter Q, go up to the top of the column, it is D. So it would be one if by land is the full decoded message. Go ahead and save this. Then save it as a PDF. Come over here, upload file, submit that PDF, move on to question 3. Again, they are out of order, so keep that in mind. They may be out of order, right? It loads a different order each time. So read about a well-known computer virus. So for this one, I chose the Morris worm. So now we're going to go over here. My name, what's the name of the virus I chose? The Morris worm. And so it's a bit redundant, but I'll state the name again. The Morris worm. So when did it first appear? November 2nd, 1988. Who who wrote it? Robert Morris. So how did it spread? It traveled via the internet by exploiting known Linux vulnerabilities. Systems attacked. DEC Vax. And Sun 3 computers running Unix. Sorry, this should say Unix. Effects. It slowed infected computers to a crawl or crash. Cure. So computer scientists analyzed the virus, right? And developed patches for software vulnerabilities. Details on how it worked. So it worked by gauging the size of the internet and it continued to reinfect machines already infected. Copycat attacks. Yes, it spawned copycat attacks. Impact. It infected roughly 10% of the internet at the time. and then perpetrator. So Robert Morris was found and became the first person convicted under the U.S. Computer Fraud and Abuse Act. He served 3 years probation, 400 hours of community service, and paid a $10,500 fine. All righty. Now we'd save this one, just rinse and repeat, right? Save the document, save it as a PDF, go over here, upload the PDF, and then that is all 3 questions for the Unit 8 challenge work. I hope that you found this video helpful. Thank you for watching. Have a great rest of your day.